Hi guys, so we're going to go through the homework help right now for 1.2.2. It's problem 70 through 74. And before I start, I'm going to put my name and date in the top right corner, as well as the title, 1.2.2, number 70 through 74. So once I'm all ready to go, I'm going to start with 1-70. Imagine that you have a bag containing 10 marbles of different colors. You have drawn a marble, recorded its color, and replaced it 50 times. And here are the following results: 9 purple, 16 orange, 6 yellow, and 19 green marbles. So now we're going to use this information to make a prediction of how many marbles of each color are in the bag. We're going to show our work and explain our reasoning. Alright, so a lot was thrown out at us, but basically what it's saying is we have this bag of marbles. And in this bag is 10 marbles. We don't know what color these 10 marbles are, though. What we do know is we stuck our hand in this bag 50 times and drew out marbles 50 times. Granted, we put the marbles back in once we took them out, but we drew out marbles 50 times. And these are the results that we got from it. We drew 9 purple marbles. We drew 16 orange marbles. We drew 6 yellow marbles. And we finally drew 19 green marbles. All right. And since we drew 50 times out of this bag, our numbers are going to be over 50, right? So out of 50 total draws, we drew out 19 green marbles, for example. And so what we're going to try to do now is create a fraction where it's out of 10 marbles, because that's how many we have in the bag. So our new denominator is going to be 10. So what I'm wondering is, how did we get from 50 to 10 as our denominator? What mathematical action did we have to make? Well, we can divide 50 by 5 to get to 10. So if we do that for all of our denominators, we also have to do that for all of our numerators, right? What we do on the bottom, we have to do to the top. So let's go ahead and do that. 9 divided by 5, 16 divided by 5, 6 divided by 5, and 19 divided by 5. So you'll notice here, our numerators do not divide neatly by 5. For example, 9 divided by 5 will give us 1.8. And we can't have 1.8 marbles in our bag of 10 marbles, right? So what we're going to have to do is round. Is there a number that 9 is close to that can be divided by 5? Well, 9 is close to 10, and 10 can be divided by 5. So we're going to do 10 divided by 5, and that equals 2. Same thing over here. Can 16 be rounded to a number that can be divided by 5? Yes. 15 is close to 16, and that's divisible by 5. And we'll get 3 as an answer there. 6 is close to 5. If we divide that by 5, we get 1. And finally, 19 is close to 20. If we do 20 divided by 5, we will get 4. So here are our predictions for how many marbles of each color are in our new bag of 10. All right. And if we add these together just to make sure that these are plausible answers, 2 plus 3 plus 1 plus 4, that does in fact equal 10. So I think those are great predictions. All right, now we're looking at 1-71. A fair number cube, really it's just saying a dice. All right, we're rolling dice here. A dice with the numbers 1, 2, 3, 4, 5, 6, so a standard dice is rolled. And now we're going to figure out what the probability of rolling an even number is. So even numbers would be 2, 4, and 6. That is 3 out of the 6 options. All right. And now I'm looking at, can I simplify this? Well, Is there a number that goes into both 3 and 6? Yes, there is. That would be 3. So if I divide both of these numbers by 3, I'm going to get 1 up top and 2 on the bottom. And so my probability of rolling an even number with a dice would be 1 out of 2, or as a percentage, 50%, or as a decimal, 0.5. All right, those are 3 ways that we can write our probability. Next, we're looking at part B. It says, what is the probability of getting a factor of 6? So I'm going to look at numbers that are a factor of 6. Well, I can multiply 1 by 6 to get 6. I can multiply 2 by 3 to get to 6. So all of those numbers go into 6. But 4 and 5, I can't multiply by any other numbers to get to 6. So looks like just 4 out of my 6 total options would work as factors of 6. And can I simplify this? Yes, 2 goes into both of these numbers. So 2 up top, 3 on the bottom. And this just means I have a 2 out of 3 chance of rolling a factor of 6. Or if you want to write it as a percentage, 67 or 66.6 repeating decimal would be our percentage, and then our decimal would be 0.67. All right, hopefully that makes sense there. Moving on to 1-72. Ramon is saving $7.75 per week to buy a new cell phone. The phone he wants costs $125. For how many weeks will he need to save his money? First, estimate your answer, and then figure out the actual number of weeks. All right, so we're actually going to get into a little bit of algebra here. And we're going to set up an equation where it's $7.75 multiplied by the number of weeks we're going to work, which in this case, we don't know how many weeks we need to work yet. Okay, so I'm going to put a little question mark in there. You could put in like X or Y or what we would call a variable, but I'm just going to put in a question mark. And in order to buy this phone, we need at least $125. So I'm going to say we need a number that is greater than or equal to $125. Okay, so I am going to guess and check here. I'm going to say maybe if we work 16 weeks, I think if we multiplied that by 7.75, we might get greater than or equal to 125. So again, the 16, that is just purely a guess, but I think it's a good guess. Feel confident. So I'm going to grab out my calculator here, and I'm going to type in 7.75, right? How much money we're making each week, and we're going to multiply it by the number of weeks we hope to work, 16, and that gives us $124. So we would be $1 short of buying that phone we want. But not all hope is lost. We now have a better idea of how many weeks we need to work. I'm going to work one more week than what I had originally thought, because that'll definitely put us over the top. So now I'm going to do 775 multiplied by 17. And here, if we take out our calculator, that should give us 131.75. Let's check. 17 multiplied by 7.75. And there we go, $131.75, which is in fact greater than 125. 131.75 is greater than or equal to $125. And so we would need to work 17 weeks. Wow, that's a lot of weeks of work to save up and buy that phone, but hopefully it's all worth it for Ramon. All right, looking at 1-73. If 18 inches is equal to 1.5 feet, how many feet is a 36-inch board, or a 72-inch board, or a 144-inch board? All right, so what we could do here is we could simply just divide these numbers by 12, and that would tell us how many feet that would be. So that's one way we could simply do it. And here we'd figure out 3 feet, 6 feet, and 12 feet. But if we really wanted to get fancy here, we could do a different way. All right, I'm looking at 18 inches equals 1.5 feet. And then my next inch length is 36 inches. And I'm noticing that 36 is twice 36 is twice. Oh my goodness. Oh, don't you just love technology? 36 is twice 18, and so I could do 18 multiplied by 2, and then I could do 1.5 multiplied by 2, and that's going to give me 3 feet. And then I can multiply 36 by 2 to get 72 inches, and multiply 3 feet by 2 to get 6 feet. And then I can also multiply 72 inches by 2 to get 144 inches, and multiply 6 feet by 2 to get 12 feet. And that's another way you can solve it. But here we use patterns rather than what we just know about feet and inches. Okay, so whether you use these formulas to figure that out, or looking at the pattern to figure it out, either way works. Okay. All right, looking at the final set of problems here, it says read this math lesson's math notes, and we're going to, on our paper, copy the incomplete axis below and write the missing numbers on each one. So we can go ahead and take a look at these math notes here. And it talks about intervals. Okay, intervals is in bright blue. You can actually click on that to get a definition. But basically what it's saying is you're going to look at the two numbers you're given, in this case 0 and 80, and you're going to look at the hash marks in between them. All right. There's 4 lengths of space between them, and so you would divide 80 by 4 to get 20, and that would be the length of your intervals. And what that means here, I'll show you, is we're going to look at the length between, say, 0 and 60. So there's 1, 2, 3 areas of space between the hash marks. And we're going to look at the number from 0 to 60. That is a distance of 60. So we're going to do 60 divided by the number of spaces we have. And that's going to be 60 divided by 20, or 30. Oh my goodness. 60 divided by 3, excuse me. And that's going to be 20. All right. So each of these hash marks will go up by 20. And as we fill that in, it looks good, makes sense. So we're going to move on to the next one. Here we have 1, 2, 3, 4 spaces between the hash marks. And we go from 0 to 60. So we're going to do 60 divided by the number of spaces, and that's going to be 60 divided by 4, which will give us 15. So we're going up by 15 each time here. And then we're at 60, and then we're at 75. All right. We're going to look at how many spaces. 1, 2, 3, 4. SP just means space. And then we go from 0 to 100. So we're going to say 100 divided by the number of spaces we have. 1, 2, 3, 4. And 100 divided by 4, that is 25. And so we're going to go up by 25 each time here. And then we hit 100, and then we're going to be at 125. All right, the very last one over here on the right, part D. Oh, please don't run out of battery on me. All right, it says 1, 2 spaces, luckily, so we got to finish quick. And we're going from 0 to 100, and so we're going to do 100 divided by 2, our number of spaces, and that will give us 50. So we're going to go up by 50 each time. And finally, 250. Awesome. So it looks like we're complete for the homework. Nice job, guys. Please submit this as a PDF if you can. Otherwise, as clearly as you can. But let me know if you have any questions. Just use this to help you out, all right? This will prepare you for your next assessment. Thank you. Have a good day.